Very good evening, everyone. Am I audible?
Yes, madam.
Okay. Just give me 5 minutes of time. I'll just start the class in 5 minutes. Hello everyone. So I discussed few questions with you guys on Thursday, and I told you guys that you can have a look at it. So did you guys went through those problems?
Yes, ma'am.
Okay, were you able to do it? The question is, were you able to do it? Yes, I did coin change one, but the rest of them I was. Okay, so coin change, were you able to do perfectly well, Kishan? You checked somewhere? Yeah, okay, that's fine if you took help. Okay, and others in the class are as usual quiet. No, does not clear how to do it. Okay, fine. And Kishan, you were having the problem with the left view of the tree, right? So basically, it was like the test case was like set incorrectly. So I just checked it and then reset the test case, which was failing, and it was working fine. So your code is perfectly fine. You can run it on other platforms and see if it is like working fine on other platforms as well. Okay. So let's start our questions now. These questions, the rod cutting problem and how much time you have given, I'm not sure of it, but I'll say that just look into these problems a little more if you guys want to. At the end, when we are done with the DP, we'll discuss these problems. Okay, because these are some additional problems which I gave you for your own practice. So it was nowhere related like covering in our course, but just an extra problem so that you can get more exposure to the DP. Clear?
Ma'am, one quick question. There is some Udemy person who did all this thing in great detail.
Mhm.
Could you share that name?
Who did it in great detail? I'm not sure like what you are trying to say.
Oh, yeah. You mentioned long ago that there is a Google person who did very good.
See, actually, the thing is in Udemy, if you see, there are lots of people who are from Google and who are posting their courses on Udemy. Okay. So
Okay.
it's not like just one specific person. It's just like I just visited one of the random videos and he was explaining just fine. So I just looked for his videos, but I was not able to find it. So you can just, if you have the Udemy access, you can just search for the data structures and algorithm regarding videos. And whatever person you get whose explanation you find that, yeah, it's okay, you can go ahead with that. Okay. Yeah. Because I was just finding his name with some random keywords because I exactly didn't remember his name. So I was not able to find. So you guys can just find the one course for yourself. Okay. Okay. Fine.
Yes. Yes.
So let's start. Today we are going to discuss the knapsack problem. So knapsack problem is basically you have been given certain items. So I'll say that there is item number 1, item number 2, and item number 3. Then you are given the weight of every item, that how much heavy or light that item is. So I'll just write the weight, that is 20, 10, and 30. The next is what is the value of that item. So the value here is 100, 60, and 120. So the question of knapsack is like you have been given items, as you have seen that you have been given the weight of the item and you have been given the respective value. Now imagine you are the stealer. Okay. So what you have to do, you have to steal from like these items are placed in some shop and you have to steal it from there. So obviously if you are some person who is stealing the things, you will try to get the things which will give you maximum profit, right? Yes or no? Yes. But the foundation here is whenever you go to steal these things, you have some bag to keep the items and it has some certain size. So let's suppose your bag has a size of 50. Now you have to fill these items in this bag, but you have to ensure that you're you are getting the maximum profit by picking up these things. Are you getting this? Yes. So now you have to choose that how you should pick the item so that you can maximize your profit. Next thing is this particular question can come in 3 variants. How? One is the items which are present in the shop are solid items. Solid items in the sense either you can pick it, either you have to leave it. It's not like that you can just break it into half and then take the half item with you and tear it, like leave the half item. You can't do that. So that comes another solid category. Next is the item is, you can say, powdery. Powdery in the sense not exactly powder. It's basically like that you can take the required quantity that you want. For example, if you have, like, let's suppose you are in a shop where you get rice. Okay. So if you have to steal the rice, you can't, you don't have to take the entire 100 kg, like whatever bag with you. You can just take few, like whatever amount of rice you want that can fill up your bag well. Are you getting it? So these are powdery items. Okay. So in powdery items, obviously, you can just partition your weight or whatever percentage of weight you want, you can take it. Remaining, you can leave it and accordingly, you can maximize your profit. Next, in the solid item, you have another 2 variants. One is that you have only one quantity of each. That is, if you pick 20, this item is gone. If you pick 10, this item is gone. So you can, this is known as 0-1 knapsack, okay? Where you can just pick or leave an item. There is no repeated item of the same. Next is like you have solid items, but there are multiple, you can say, the availability of it. That is, if you pick this 20, there is another same kind of item present. So if you want, you can take it again. Are you getting it? So this is known as infinite naps. Yes.
What is like nap? Like how many items I can take? Like 0-1, like could be.
Sack is basically, you can say, the bag you have is known as sack.
Yeah.
Okay. And how many items you can take? You have the quantity here, right? K equals to 50. Your particular bag has a quantity of 50 only. So let's suppose I picked up this 20. And then I picked up this item like with weight 10. So already my, like, out of 50 kgs, 30 kgs is filled, right?
Yeah. Yeah. I
Can I
can't
take
take.
this now?
No.
No. Next possibility which I can have is,
2 of 20 and 1 of 10.
no, that comes under the category of infinite knapsack, right?
Okay.
But if it is a 0-1 knapsack, you can pick a 30 and you can pick a 20. Your bag will be filled and you will be getting the maximum profit as well.
Right.
Yes.
Yeah.
So basically, in this question, our main target is the 01 knapsack. It's the most asked question you can say by the interviewers. Remainings are something which are the analysis which you need to do in order to understand that, okay, if this is the particular possibility, what should be done? Clear?
Yeah, ma'am, just one suggestion. Instead of this word steal, like we can say a kid goes to the shop and that these are the Cadbury's or whatever, and then he chooses maximum value. That
See,
means
a kid, hello,
just guilty, like thinking about it. Yeah.
a kid never wants to maximize his profit. So the perfect thing for that is robbery only. A person is robbing it, or a thief, you can say. You can't blame these things on a kid, okay?
Yeah, but it
Yeah,
feels very like guilty that I'm a robber and trying to think in that way.
it's just a problem. It nullifies your guilty.
Okay, okay.
Yeah. Okay. So did you understood till here so far? So now we will one by one. Here, instead of powdery, it's just an informal language which I told. You can say it as in fractional. Basically, you can take fractions of the, like, whatever thing you are choosing and take the fraction of it and like just go ahead. Now, just tell me amongst like the given example which I've given you, what will be the max profit you will have in 01 knapsack? What will be the max profit you will have in infinite knapsack? And what will be the max profit you are going to earn in fractional knapsack? Is my question clear to you all? Okay, now take 2 or 3 minutes of time and calculate it and then let me know. Okay, so max profit of 01 knapsack is gonna be 220. Fine. Okay, the last one is fractional knapsack.
With infinite knapsack,
Mhm.
he will take two of 10 10, so it will be 240.
2 of 10 will be 120, not 240.
Yeah, yeah. And then the remaining is 30. So 10 10 and 30 will make it
And
240.
what if you take 10 5 times?
Yeah,
So that will be
300.
300. That is the max profit, right? So
Yeah.
here it's basically 60 into 5, which gives you 300. For 01 knapsack, it's like given here only. You pick 20, you pick 30, and you are done. So 100 plus 120, it's give you 220. How fractional works here? Okay, I'll tell you. So basically, to maximize your profit, see, you picked up 100, you picked up 60 entirely. Now you are only left to pick like your bag has a capacity of 20 only, and the remaining item has a like weight of 30. So what will you do? 20 divided by 30 into whatever its value is, that is 120. So it's 4, it's gonna give you 80. Overall, it's gonna give you the profit of 240. So you can see the max profit gets in terms of infinite knapsack. You can consider it as an example of you are stealing in some supermarket, or where you like supermarket, you can say, or you can say some clothes store. There are multiple occurrences of the same thing. You can just pick all the th like all those things which can give you the max profit infinite times. Are you guys clear with all the three types of knapsack?
So in the powdery, just the third item is fractional, or
Yeah, because like, see, I went and see 20 kg. I was like, okay, this is it. Allowing my bag limits. I'll pick it up. Okay. Next, I went to 10. I was like, okay, this is also allowing my bag limits. I'll pick it. When I went to 30, it's like that. No, it's not allowing my bag limits. I just took the fractional one.
so in that case, I was thinking that 30 times
Okay.
5. I mean,
Why
say
30 times 5?
no, sorry. What I'm thinking is the 31 weight one. I take it 1 plus 2 third will give me much more.
You can just take this problem as a
Okay, fine, fine.
homework, and you can tell me if any better fractional solution is possible for this. Okay. Is it okay?
Oh, yeah, yeah.
Okay. So if I talk about the fractional knapsack, can you do it on your own? Is it easy? Is it not? See, for fractional, you can do one thing. If you have, let's suppose, weight and value. So weight here is 20, value is 100, weight here is 10, value is 60, and weight here is 30, and the value is 120. So if you have to like find out that which particular value is gonna give you the maximum profit, you can just find out their ratio. So 20 divided by 100 or 100 divided by 20, you will have 5 here. 60 divided by 10, you will have 6 here. 120 divided by 3, you will have 3 here. Sorry, 4 here. So in terms of percentage, you will have an idea that which particular item is gonna yield you the maximum profit. So if you see with a weight of 10, you are getting a profit of 60, which is a great deal. So you will pick up this item entirely. So now your bag is filled with 10 kgs. Next, comparing the other twos, you will see that 5 is better than 4. You pick up 4 like you will see if the weight is permitting you or not. So its weight is 20, it's permitting you. So you will pick up this. That is, your profit has now become 60 plus 100. Next, the remaining one is 31. You will see that, okay, I have to pick this up, but your bag limit doesn't allow you. So now you will find its fraction and then you will take it accordingly. Clear? Are you guys clear?
Ma'am, yeah, I got it that for every 1 kg, how much value I'm getting. So if 6 is there, then we are assuming that there's not an infinite knapsack. That's why we are going
We
for.
are discussing for
Yeah,
fractional
yeah.
knapsack, right?
Okay, okay, got
Yeah.
it.
No, we are not assuming. We are specifically discussing for fractional knapsack. Let me put a heading also.
Okay, got it. Now I'm clear. But if I have to make it into a coding thing, then yeah, it if it is a single item, then there's no need for DP. It's just like simple addition. No,
Sorry?
one. So I'm just thinking that if we break down into weight, मतलब value per weight, then it's no more a DP problem.
I never said it's a DP problem. Did I say it?
Oh, no, no. Actually, I was thinking of that.
I was just telling you what is knapsack, what are the types of knapsack, and then we were starting on how to solve it.
Got it.
Correct?
Yeah.
Yeah. So now we will discuss its time complexity. So time complexity here goes, you have to find the ratios first. So in order to know that which one you have to pick first, which one you have to pick last, that is going to take your end time because you have to find the ratio of all, right? Then what is the other thing you need to do?
I mean,
You need
everything
to,
space would also be n because every atom would have one space. No.
yep. But see, what can we do possibly is that um, according to the ratio you got, you're picking up the object, right? So you find out the ratio and you try to store it in a map. Okay, basically, precisely, if I'll say tree map. So if you use tree map in order to do the sorting, just give me a minute. So you store it in a tree map. So what it will do, it will give you a sorted data as well. So it will be very easy to pick the data and just add it to your profit and at the end give your result. Are you guys getting it? N log n, basically tree map will take the time for sorting and all. So this is for that. That is storing your ratios, and end time it will take for selecting your items, because obviously you can't select all the items of the tree map. You have to see what are your capacity of the bag, and according to that you have to pick your. Are you guys clear?
No, ma'am. Actually, like n log n is for collecting the items, n items, and log n is for sorting.
I am not getting you.
Oh, so in this n plus log n plus n, I'm not clear. Like,
N
uh,
is for finding out the ratios of every data.
okay,
You figured out the data, now you have to store it, right?
yeah,
For storing, it takes
n
n
log n,
log n time.
right?
Then after storing it, you have to pick your items one by one, right?
Yeah,
Yeah. So that is gonna take another n. What is the confusion?
okay. Then this is the total time complexity.
Yeah,
Okay, got it.
clear?
Yeah, yeah, now clear. Thank you.
You can think of that how can you optimize the space. I'm telling you to use here the tree map, but you can think how can you optimize your space to one. Okay, so next is, if you guys are okay with these, next question is, like we are done with the fractional one. Now we are moving to the solid knapsack, like solid object knapsack. So do you guys think that the answer of the infinite knapsack is always greater than the answer of 0 1 knapsack? Greater
It,
or equal. Okay, say
it depends on the type of items.
how it depends on the type of items. You are a thief and you only have to look towards your profit, not the type of item you have.
Okay. Okay, then always infinite knapsack will give a better results than
Correct.
zero
Like
knapsack.
whatever value you get, the better, or you can say the better profit, you will pick it up in the infinite times, right?
Yeah.
Okay. So now moving towards the solution of infinite knapsack and zero one knapsack. Any ideas how it can be solved?
I think the same way, like first calculate the maximum value for given weight, then infinite knapsack is multiplied with n times.
You are saying find out the ratios.
Sort them, sort the items
Okay.
based on.
According to the zero one knapsack, that the approach which you are suggesting, you are saying that we should pick up 60 first, then we should pick up 20 first, and then we have to pick 30, right? If you are considering the ratios, right?
Yeah.
Is it going to give you the correct result?
Yeah, for 01, yes.
No, it won't. Because if you pick 10, it will add the value of 60. If you will pick the weight of 20, it will add the value of 100. Overall, the value will be 160. If you try to add 30, you won't be able to because your knapsack size is 50 and overall profit that you will earn is 160. But the actual answer that we calculated manually is 220. Because if you will pick 20 and 30 kgs weight, you are going to get the profit of 100 plus 120, that is 220. Are you getting this?
Yeah, I thought that bag was infinite.
See, one thing at a time. Bag is never infinite. Whenever you are going for stealing, you can't just keep the entire shop in your bag, right? You always have some limited space. So always the bag size is a restriction, first thing. Previously, we were discussing for fractional knapsack, that is done. Now we are discussing for zero one knapsack and infinite knapsack. Clear? So you guys understand that what should I say? That for zero one knapsack, basically this ratio approach is not gonna work. Yes or no? Basically, it is called a greedy approach. That whichever item is giving you the maximum ratio or maximum profit, pick it first. It's called a greedy approach. So greedy approach is not applicable for zero one knapsack. Clear, everyone? Yes. Now, like, is the greedy approach applicable for infinite knapsack? Yes. For this example, yes, it is working fine. But I want you guys to like see, like look into this particular infinite knapsack thing for some time, like as an homework today, and tell me if there is any possible example which can give, like, which can prove it wrong. I'm not going to tell you the exact answer here, but I'm just want you to do the research on it. Clear?
So the question is, using greedy approach, how can we solve 0 1 knapsack?
I just have written in the screen.
Yeah, no, no, I got this part. I didn't get what to think about.
I said is greedy approach can be applied on infinite knapsack, not 0 1 knapsack. And I just told you, just
Yeah,
search for some examples which can prove this theory wrong, that greedy approach is not applicable for 0 1 knapsack. If you guys are not able to find it, then we can conclude that yes, infinite knapsack can be solved using the greedy approach. Clear?
yes.
Okay. Now we'll see that how can we solve this DP problem. So the very, very basic approach which we can follow here is sorry. For your given 0 1 knapsack, whatever you have been given the values of the weight, you just find out the subset of all of your array which is given to you of weight. Okay. And then what you can do, that when you have all the subsets, you can find out the weights which you will get out of those subsets. So in the subset, whatever is matching your weight range and whatever is giving you the maximum value, you have to take that as your answer. Are you guys able to follow this? Yes, but this is going to take your 2 to the power n time multiplied by n time, because every time you have to see that whether the weight is matching with the weight of your bag or not. And then you have to calculate the value at the same time. So that is going to consume your n time. So this much heavy solution is not possible, right? Because at any point, if someone gives you more values, more values, you won't be able to do it properly. So now you guys can see our problem involves maximizing our profit, right? And there are many ways to do it. It just depends on the which way you want to solve your problem. So whenever some maximizing or minimizing things comes into picture, we have seen which kind of solution we can implement. Not Kadane is exactly like Kadane is something which you went into depth, but you can say we can implement DP into those problems. Like whenever you have to get the optimal substructure, you have to follow the DP problems, right? This particular problem also follows overlapping subproblems. Overlapping subproblems, how? Like let's suppose you are at the initial point. You want to pick the one item, you will pick it. You have a choice, you won't pick the other item. Other, when you come to this point, you will pick the second item. Either you will pick it or you will leave it. Okay, so this leave it, pick it, it makes your problem comes into the category of overlapping subproblems. Okay, okay. I'll just write here. Take it or leave it. Everyone clear till now? So how this problem is gonna get solved? I'll just depict you the structure here. You are at the initial point, you have your bag empty and you have n items in front of you. So basically you have n items and a knapsack bag of k size. So you can go with two choices. Either you can choose to skip the item which you are having right now. So the skipped item basically will reduce one item from the list of items and k will remain as it is because you have skipped it. If you are going to pick it, obviously again one item is going to get reduced, but the weight is also going to get reduced. So it's going to be k minus w of n, whatever the value of whatever the weight of nth item was. Clear? Along with that, whatever your DP state was currently, plus you're going to add the value of n. Right now, are you guys clear? So basically, your task is to find out that if you take this item, you're going to get maximum profit from this end, or you're going to get the maximum profit from this end. Whatever is the maximum, that is going to be your answer. Clear? Yes. Okay. So if I have to define a DP state, can anyone help me with that? It's basically DP of IJ. You have I items and J is the size of your bag. You can say that the max profit you will get, max profit to fill knapsack of size J with the first I item. Clear, everyone? Okay. If I have to write DP expression, what will it be? DP of I comma J again. Here, the value of I ranges from 1 item till n item it can have, and the value of J ranges from 0. You choose to pick no item, so 0. Or let's suppose your bag size is 0, that again 0, till K, whatever max weight you have been given. Clear? Next is you have to, since you have to get the max, I'll just write max in front. One is you are picking up the item, so that will do DP of I minus 1, sorry, comma J minus W of I close the small bracket, plus you have to add the value v of I, comma, dp of I minus 1, comma, j. Close it, close it. Whatever the maximum profit you're getting from either of these, that's going to be your answer. Next, you have to always ensure that this j minus w of I, that whenever you are reducing your bag weight, it should be either greater than or equals to 0. It should not go negative. Correct? So this is the part which we call as, if you take it, and this is a part where we call it as the don't take it. Clear? Clear, everyone? The remaining things here is base condition. What will be your base condition? So the base condition is, if let's suppose there exists a scene dp of where there are no items present, that is 0. And you all have understood till now that we are going to have a dp like 2D dp, right? Or not?
Once again, what is we are doing the base condition.
Yeah,
So
but you guys have understood that it's a 2D dp, right?
yeah, 2D in the sense that
Because I and j we are using, right?
I mean see it as weight as well as value.
Correct, but that comes as 2D dp, right? You have to store your answer in a form of 2D dp.
Okay, yeah,
Clear, no?
yeah.
Okay. So for that, this is your 2D dp. This zero space which will be created here, everything, you just fill it with zeros. That is dp of 0, comma j will be equals to 0 for all j equals to 0 till k. Clear? Okay. Did you guys were able to follow up with me when I was explaining this particular problem, like the dp state, the dp expression and all? Okay, great. So now your task is to analyze the base conditions, time complexity, table space, space complexity, answer, where you will get your answer, any space optimization possible or not, and 10 points. Yeah, correct, 10 points. And you have to write down the answer for this, that is the solution for this, and come back with the solution tomorrow. Are you clear with your task? Yes, good one. So if you guys are clear with your task, then try to do the solution. And if you are able to do it, well and good. Otherwise, I will just give you the solution tomorrow. Clear, everyone? And yes, also make sure that you find out that if we can solve infinite knapsack using the greedy approach or not. That is also one thing which you need to do. Clear? Okay, so that is it for today. I'll just stop the class here now and I'll see you guys tomorrow. So, okay, have a good week ahead, and we'll see you guys tomorrow. Bye bye. And probably I'll just try to wrap up this particular, like, what should I say, the batch by the end of July. Okay, because we are almost at the end of DP. Next, we have to do graphs. Graphs are not that much questions we have, only the basics which are being asked in the interviews, and then we are to the bit manipulation and then the miscellaneous sessions. So it's not that much. So I'll try to wrap up this course this month. Okay. It has been extended a little bit, but I think I have covered all the topics very well. There has been little gaps, but not that much big. So I think this particular batch has went very well for me. I'm not sure about you guys. You can give your feedbacks. So that's it from my end.
So what is remaining is trees.
Trees, no.
No, no, no. Sorry, not trees. Graphs.
Graph is remaining,
Yeah.
and bit manipulation is remaining because it's a topic which is very different from all the topics which we have done so far. So that will be discussed in the end, and it's like the questions are very interesting in bit manipulation. So it's just, you can say, a rewind mood after trees, graph, and DP. So you can do it pretty well. After that, the miscellaneous ones and the topics which I the small topics which I have not discussed so far, like tries. I have said you guys that I have not discussed. So those questions I will discuss at the end. Clear?
Yes.
Other than that, your practice matters a lot. So continue your practice. Start doing your practice if you have not done. And yeah, that's it. Okay.
Yeah.
Okay. So thank you for attending today's session, and have bye bye.
Thank you.